Hi all, welcome to another video of subject DC machines and transformers, and we are on module 3, and today we are going to discuss different starters we are using for DC motors. So as we know, we need a starter. We need a starter for starting the DC motor. So the main function of the starter is to reduce the starting current, because when the motor is at rest, the speed of the motor is 0, that we know. Therefore the back EMF EB will be is equal to 0, and we know that the equation for armature current is V minus EB by RA. So at the starting initial condition, if EB is 0, then IA will be only is equal to V by RA, and we know that the value of RA is very small, so a large current will drawn from the supply. So this will damage the motor, damage the winding. So for reducing this starting current, inrush current, we have to use starters. So mainly we are using two different types of starters in the case of a DC shunt and compound motors. So among that, the first one is a 3-point starter. So we are calling it as a 3-point starter because it is having only 3 points. 3 terminals are the line, then F and A, that is field, armature, line, field and armature. So the figure of a 3-point starter is shown in here. Here you can see it consists of a series starting resistance divided into several sections and connected to a brass studs, and you can see a brass arc here, and from that brass arc we have connected a holding coil or no volt release here, and it is connected to a shunt field coil. And here in series with the line terminal, we have connected an overload release. This overload release and no volt release, both are the protections provided in this 3-point starter, and it is directly connected to the starter arm. And you can see a soft hand keeper here, and we are using a spring. Spring S here. So this soft iron keeper is attached to the starter arm, which is pulled by the holding coil. Holding coil here, or no volt release under normal running condition. So we can explain the operation. Next we are going to explain the operation of this 3-point starter. So when the motor is at rest, the starter arm is in off position, that is this arm is in off position, and physically we can see a knob here, and we will move that knob to the clockwise direction for starting the motor. So initially this starter arm is in off position, mainly due to the action of this spiral spring. We have connected a spring here, so due to the action of the spring, the starter arm will keep in the off position when the motor is at rest. For starting the motor, the DC supply, here the DC supply is switched on by closing the main switch and keeping the starter arm in off position. The starter arm is then turned clockwise. We can see a knob here. And by pulling that knob, we are moving the starter arm in the clockwise direction. In the clockwise direction to the first stud. We will connect it to the first stud and this brass arc assembly. So when this starter arm is connected to the first stud, we know that all of these resistances, that is all of the starting resistance R is inserted in series with the armature. The field winding is directly the field winding is directly connected across supply through this brass arc. Okay, you can see a brass arc here. When this starter arm is connected with the stud 1 and this brass arc, the armature is connected with the series resistance, all of the series resistance, and the field winding is connected through this brass arc. Okay, so this brass arc. So as soon as it comes in contact with the first stud, all of the starting resistance R is inserted in series with the winding. Okay, so as the starter arm is turned further, the starting resistance is cut out of the armature circuit in steps, and finally entire starting resistance R is cut out of the armature circuit. By step we will cut this starting resistance. Okay, because in the initial time only the back EMF EB, okay, the back EMF EB will be 0 when the motor is at rest, but when the motor began to run, EB will develop. Okay, so of course the current will reduce, so we can simply cut out all these resistance by step by step. Okay, in step by step. So when the starter arm reaches the on position, that is, this is the on position, it is held against the action of this spiral spring S by the force of attraction between the holding coil magnet and soft iron keeper attached to the starter arm. Okay, because this holding coil is also energized here, that is, it is connected in series with the brass arc, so the same shunt field current is flowing through this holding coil, so it is energized. So when this soft iron keeper, that is, when this starter arm comes here, okay, when this starter arm comes here, so this holding coil will attract this soft iron piece, and the starter arm will stick on this position. Okay, stick on this position. So the resistance is completely cut off, okay, when the starter reaches the on position and the motor starts running at a normal speed. So if the supply gets interrupted, okay, suppose if the supply gets interrupted or disconnected, okay, while the motor is working, okay, so if this holding coil is not here, if this holding coil is not here, this starter arm, of course the starter arm will keep this on position. Okay, that is, if the supply is interrupted, okay, if it is disconnected suddenly, if it is disconnected, okay, this starter arm, the starter arm will keep this on position. Okay, so what happens? Okay, that is, if this starter arm is in this position, what will happen? If the supply is back, of course there is no resistance in the path, the supply current, okay, supply current is directly flowing through this armature, so armature resistance is very small, so large excessive current, so it will draw a large excessive current from supply and it may get damage the armature. Okay, so this holding coil, okay, so the function of this holding coil is very important. So initially we will move this starter arm from the off position to on position. When it reaches the on position, this holding coil will hold this starter arm in this position. Okay, here will hold this starter arm here. Okay, and one more advantage is the for this holding coil, that is, if this is a shunt machine, we know it is a shunt machine. Okay, so for any reason, if this shunt field is disconnected, okay, if this shunt field is disconnected, what will happen? That is, of course, the flux, okay, the flux phi will suddenly drops. Okay, if this shunt field is disconnected from the supply, this phi will suddenly drops. Okay, so what happens to the speed? We know that N is directly proportional to EB by phi. So when flux phi reduces, speed dangerously increase. Okay, so for avoiding that, we have to use this holding coil. Okay, so if this shunt field is disconnected, we know that this holding coil is also connected in series with the shunt field. So if this shunt field is disconnected, this holding coil will de-energize, and of course the starter arm will move from this on position to the off position due to the spring action here. Okay, so actually that's the role of this holding coil or no volt release here. And one more protection we are using here, that is overload release. This is the overload release. Actually this coil is also connected in series with the armature. So of course the rated current, okay, when the starter arm is in on position, the rated current is flowing through this overload release, this coil. And for any reason, if when the motor is overloaded, it draws heavy current, okay, which also flows through this overload release, okay, this coil, and it will magnetize it to such an extent that it pulls its armature. That is, its armature is this one. Okay, so this overload release will pulls its armature upward, okay, upward, and so it will short circuit this no volt release. Okay, you can see a connection here. When this part move upwards, okay, these two point will get short circuited. That is the holding coil or no volt release is short circuited here. Okay, so the no volt release coil being short circuited, it demagnetizes and release the starting arm, which goes back to the off position. Okay, mainly due to the spring action here. So thus the motor is disconnected from the supply and is protected against overloading. Okay, so the starters for motors up to 15 kilowatt are provided with overload release to disconnect the motor from the supply mains. Okay, in the event of an overload and all. So actually this is a 3-point starter. This is the actual working of a 3-point starter. So for a 3-point starter, 3 point will be the line, field and armature. So initially the starter arm is in off position, and we will move the starter arm clockwise, and it will reach the on position. Okay, it will reach the on position. So initially by moving the starter arm, we are including all these resistances in the armature circuit, and later we will simply cut down these resistances, and it will the current will reach the rated current when it is in on position. Okay, and here the holding coil will keep this starter arm in the on position, okay, by simply attracting the soft iron keeper attached with the starter arm. Okay, and also this is one mode of protection here, and another overload protection is also provided here. Okay, so I hope all of you understand the 3-point starter well. So thank you.